Yes, good evening students, and today class we discuss about important questions in the topic of the organic chemistry, right? Now see the questions carefully because organic chemistry is somewhat difficult. Listen the questions carefully, right? See the first question, Anna. Describe two methods. Describe two methods of preparation of what? Ethylene. What is ethylene? C2H4 gas is called ethylene, right? Give the equation for the reaction of ethylene with what? Ozone hypohalous acid, KMNO4 heat with O2 gas under high pressure. Right, Nana? Yes. First go to the question. So, describe 2 minutes of preparation of ethylene. First one. So, the first reaction is very easy. First one, you write from Nana organic chemistry somewhat difficult, listen carefully. 1,2 dibromoethane. Tell me the first preparation from what? 1,2 dibromopropane. So 1,2 dibromopropane subjected to heating. So bromine here, CH2Br again single bond CH2Br. 1,2 dibromopropane, right? Yes, Nana. Now to this heat with what? Alcoholic KOH. Tell me what I am saying. Alcoholic KOH. So you can use alcoholic zinc dust. That means what? Zinc dust. Heat with zinc dust. Yes, zinc valence is what? Zinc valence is +2. And bromine leave as what, Nana? Br minus, Br minus. On heating, loss of ZnBr2 and you get what? CH2 double bond CH2. You get ethene gas is liberated. Tell me what liberated, students? Ethene gas is liberated. Simple explanation, no confusion. That is from 1,2-dibromoethane. Understood what I am saying? So 1,2-dibromoethane heated with alcoholic zinc dust. Zinc is what? +2 state. Br minus loss of ZnBr2 and you get ethene gas is liberated. And go to the second method of the preparation. Second method of preparation is what? By dehydrohalogenation. Tell me by what I am saying? By dehydrohalogenation. What is the meaning of dehydrohalogenation? Dehydrohalogenation means removal of H atom and halogen atoms. Tell me what I have said, students. Removal of what? Removal of the H atom and halogen atoms by dehydrohalogenation. Understood what I am saying? By dehydrohalogenation, removal of the H atom and halogen atoms. Understood, Nana? Yes. Now, for example, you take the example CH2X. I am writing here CH2H. Simple explanation, students, no confusion. Heat with what? Heat with alcoholic KOH. What is alcoholic KOH? KOH dissolved with the water. Now the OH minus is the strongest base. The strongest base remove the hydrogen as H plus ion. Now the H plus ion combines with this OH minus remove the hydrogen as H plus ion. Loss of the H2O. You are very well known. Halogen carries negative charge. On heating, halogen leave as what? X minus CH2 plus. Loss of what? Kx. Loss of what, students? Kx. Now K plus combines with what? X minus loss of the Kx. That is called dehydrohalogenation. That means H plus ion is removed by using strong base of the OH minus and X minus ion removed in the form of the Kx. And what you get, Nana? And you get CH2 double bond CH2. This is the preparation of what? Preparation of the ethylene gas. Ethylene gas also called what? Ethylene gas also called ethene gas. Simple explanation, no confusion. This is the second method of the preparation, that is called dehydrohalogenation. Understood what I am saying? No, this is the 8 marks question. Chandrahasini. This is the 8 marks question. What is given question? Describe any 2 minutes of preparation of ethylene. Give the reaction. So this carries what? This carries 4 marks and each reaction carries 1 mark. Understood, Nana? Chandrahasini. Yes. And come to the given reaction. The first reaction is what? Ethene gas react with what? Ethene gas react with ozone. What is ozone, Nana? O3 gas. Simple explanation. How the ethene gas react with the ozone gas. Now, how you write? Ethene means what you write? CH2 double bond CH2 is the ethene gas. To this ethene gas, send out the ozone gas. Ozone gas itself is what, Nana? Unstable. Okay, so ozone gas is what, Nana? Unstable. That's why the ozone gas attack on the pi bond is big bond, na? And you get what? CH2 O, and you get what? CH2O, and you get ethylene ozonoid. Tell me what is forming? Ethylene ozonoid is forming. This is the simple explanation. Have no confusion on the explanation. But we write in the IPE point of view, you write the equation and write the statement. Ethene gas react with the ozone gas. Tell me, ethene gas react with ozone gas at temperature of -70 because ozone gas is very unstable now, and you get ethylene ozonoid. The first reaction completed, and come to the second reaction, hypohalous acid. Easy, Nana. So what is hypohalous acid? Second one. So ethene gas react with what? C2H4 gas react with hypohalous acid. What is hypohalous acid? HOX. What is hypohalous acid? HOX. Now for that, what you write? CH2 double bond CH2 is the ethene gas. To that, adding of what? So hypohalous acid. You are very well known. Oxygen is more ion value compared to the halogen. That's why on heating, the sigma bond electrons are moving towards what side? The sigma bond electrons are moving towards the oxygen side, that is more ion value. Simple logic compared to the halogen. Halogen of the chlorine, bromine, iodine. Compared to halogen of what? Chlorine, bromine, iodine. Understood what I am saying? That's why oxygen is more ion value on heating. Sigma bond electrons are moving towards the oxygen side. This kind of logics are not there in the materials. Just in the material equation is given. So the sigma bond moving towards the oxygen side, minus plus, the symbols are not given. The symbols get by the logics of the, by explaining the teacher on the board. Now here the pi bond shifted to one of the carbon side. Shifted like this, and you get negative charge and we get positive charge. Now OH minus attack on the CH2 plus, X plus attack on the CH2 minus. By that, what you got? You get CH2OH single bond CH2X. Now this is called haloethanol is forming. What is the molecule is forming? Haloethanol. Simply called, the common name is called halohydrine. Tell me the common name. Halohydrine formation observed. Halohydrine means what? Haloethanol formation is observed. That is the ethene gas react with what? HOX. And come to next one, cold dilute alkaline KMnO4. Now see that. So reaction with what? Ethene gas react with cold dilute alkaline KMnO4. Cold dilute alkaline KMnO4, potassium permanganate. What I am saying, students? Ethene gas react with cold dilute alkaline KMnO4. What is dilute? Water. KMnO4 is the one of the oxidizing agent. Simple explanation. CH2 double bond CH2. Ethene gas. So react with what? Ice cold condition. Dilute means what? Excess water. KMnO4 is the one of the oxidizing agent. Because of the oxidizing agent, it gives what? Nascent oxygen. H2O plus O. What you get? H2O plus O, you get H2O2. H2O2, how you write, Nana? H2O2 is very unstable, Nana. Are Nana, easy explanation. H2O, dilute means H2O. KMnO4 is the oxidizing agent, gives nascent oxygen. H2O2 means what you write? OH dot, OH dot. Now, in the ethene, the pi bond is breakdown. Now, the pi bond is what? Breakdown. And one OH dot attack here, and one OH dot attack here. Now, by that, what you get? CH2OH, single bond CH2OH. Now, you get what? You get ethane 1,2-diol. Tell me, students, what you got? Ethane 1,2-diol. Its common name is what? Ethylene glycol. What is the common name, students? But in the organic chemistry, one important point is there. Please remember that point. The writing of the name is very important. To make the examiner more impression, the product name writing is very important. Better to practice the product name also, along with the product formation. Understood what I am saying, Nana? Yes, yes. So what you get? Ethane 1,2-diol is the IUPAC name, and common name is what? Ethylene glycol. This is the third reaction. And come to the fourth reaction. So what is the fourth reaction is given? So ethene gas. The fourth reaction given is what? Ethene gas react with what? Ethene gas react with O2 gas. What I am saying? Ethene gas react with O2 gas under high pressure. Simple explanation. Ethene gas react with O2 gas under high pressure. So it's very easy explanation. See, ethene gas means what? CH2 double bond CH2. So O2 gas react with under high pressure. When O2 gas react with under high pressure, I am writing O2 gas like this. Half O2 gas. Half O2 gas means what? Half O2 gas means nascent oxygen atom. What is nascent oxygen atom? Nascent oxygen atom have 6 electrons. Oxygen belongs to 6th group now. Now, one of the pi bond is breakdown. What you get? Dot here, dot here. Now, this electron combines with this dot of the pi bond. This electron combines with dot, this dot of the pi bond. And what you get? And you get CH2 single bond, CH2, and you got what? Ethylene oxide. And what is forming? Ethylene oxide is forming. Its common name is what? The common name is ethylene oxide, simply called epoxide. What is the name of this? Epoxide. This is also called what, students? Oxirane. What is the name of this? Oxirane. Ethylene oxide or epoxide is called oxirane. Cyclic ether is formed. Simple logic, Nana. When heat with the water gas under high pressure, I am writing half O2 gas. Oxygen atom belongs to what? 6th group now. We have 6 electrons. So one of the pi bond breakdown. One of the electron of the oxygen. What I am saying? One of the electron of the oxygen attack on this pi bond have the dot. One of the electron of the oxygen attack on this pi bond have the dot. And you get what? Ethylene oxide or epoxide or oxirane. Understood what I am saying? Simple logic. Successfully the first 8 months question completed. Nana, very easy, Nana, no confusion, right? And go for the next question. So this is the important question. Give 2 methods of preparation of what? Acetylene. How does the acetylene react with the water and ozone? First, preparation methods of acetylene. First one, preparation from what? Preparation from the calcium carbide. From what, Nana? Calcium carbide. So what is the formula of calcium carbide? CaC2 solid. What is the formula of calcium carbide, Nana? CaC2 solid. From CaC2 solid, you know calcium carbide, calcium plus 2, and what you write? C minus and C minus is plus 2, and this minus, this plus 2 minus, and interaction is there. This triple bond is like that. Is a calcium carbide. Very nice, easy explanation. You can practice like what I am writing on the board now. Easy to understood what you got the answers. Subjected to what? Hydrolysis. What is the symbol of hydrolysis? H plus OH minus. Symbol of hydrolysis is what? H plus OH minus. Just on heating, what happens? Now the simple explanation: the H plus ion attack on the C minus, the H plus ion attack on the C minus, and Ca plus to combines with what? OH minus, and you get aqueous solution of the calcium hydroxide plus acetylene gas is liberated. Tell me, students, what you got? So acetylene gas is what? Acetylene gas is liberated. The simple explanation, no confusion of the explanation. Now this is acetylene gas is also called what? Acetylene gas is also called ethane gas. What I am saying, students? Acetylene gas is also called what, Nana? Ethane gas. Clear? Now how does it react with the water, and how does it react with the ozone? Simple logic. First one, so the acetylene gas, what is acetylene? CH triple bond CH. Acetylene gas react with water. It's a simple reaction. Acetylene gas is react with water. Water. So for water, so what the catalyst is used? 1% of the mercuric sulfate is used as a catalyst. Used as what, students? Used as a catalyst for addition of the water over the acetylene. Now how you write, Nana? CH triple bond CH. So in the presence of the characteristic, by adding of water, what is water, students? H plus OH minus. Understood? Now again this very simple logic. So one of the pi bond is shifted like this. What you get negative charge here, get positive charge here. Now H plus ion attack on the C minus and OH minus ion attack on the C plus. See what I am writing on the board, you can practice like that, now easy to understood. Understood, Nana? Jayan, Nana respond. Jayan and you, Chandrahasni, clear, Nana? Yes, Nana? It's clear? Yeah. Now what happens now here? You get CH, OH. S oxygen have the two lone pairs because of sister group, and you get double bond CH2 you got. Now this is called vinyl alcohol. Now this vinyl alcohol is called what? Enol form. What is enol? En plus al. En means what? Double bond. Al means what? Alcohol. That is called enol form. Now generally this enol form is what, students? The enol form is unstable form. So the unstable form of the enol changes to what? Changes to keto form. Because enol form is itself is what? Enol form is itself is unstable, students. Now here, so sigma bond and is the pi bond. Pi bond is weak bond shift like this now. O minus C plus. Now because of the En difference, what you write? O minus H plus. Now because of the En difference, what is En? Electronegativity difference. What is En difference? Electronegativity difference. Now the H plus ion attack on the what? H plus ion attack on the C minus. Now what you get? You get CH double bond O. This oxygen have the two lone pairs and make a single bond and you get CH3. Now you got what? And you got acetaldehyde. Tell me, students, acetaldehyde is forming. Now this is called keto form. Now this is called keto-enol tatomerism. On the arrow mark on equilibrium symbol you write like this. Is a tatomerized. Enol form is tatomerized to aldehyde form. Tell me what I am saying, students. Enol form is tatomerized to what? Enol form is tatomerized to aldehyde form. Understood what am I saying? So this is the reaction with water. Nana is clear? Simple logic, Nana. Enol form is unstable now. In unstable form of enol, the pi bond shifted to this carbon side C minus C plus. In the OH group, because of the electronegativity difference O minus H plus. H plus and attack on the what? H plus and attack on the C minus, that becomes CH3. C plus and O minus you get C double bond O and you get acetaldehyde. Enol form changes to acetaldehyde. So reaction with water completed. Understood what I am saying? And next one, reaction. Well, acetylene gas is reaction with ozone. That is very easy now. Acetylene gas reaction with what? Acetylene gas is reaction with ozone. Now see, simple explanation. See, acetylene gas is combined with what? Is combined with ozone gas. Now when acetylene gas is combined with the ozone gas, what you get? You get CH, O, CH, and what you get? O, and you get O. This is called what? So this is called acetylene ozonide is forming. Tell me, students, what is forming? Acetylene ozonide is forming. Simple reaction like that. We got acetylene ozonide because carbon valence is what? Carbon valence is 4. That is, we got acetylene ozonide is forming. Simple reaction. When acetylene gas react with what? Ozone gas, and you get acetylene ozonide. Please tell me what I am saying. Acetylene ozonide. Clear, Nana? Yes, very good, Nana Chandrahasni. So this reaction completed. But on the board, I am writing the reactions. But in the IPE paper, you write the first statement. How you write the statement? Acetylene gas react with the ozone gas forms acetylene ozonide. Now you write that equation. Now the examiner is more impressed. Acetylene react with water forms what? Vinyl alcohol. Unstable form tatomerized to acetaldehyde. First you write the statement like that and write the mentioned equation. Now the examiner is more impressed in the organic chemistry. Right, Nana? Yes. And go to the next question. How does acetylene react with the following reagents? Give corresponding equations, name of the product to the following reaction. First one, acetylene is react with what? Acetylene is react with acetic acid. First one is what, Nana? With acetic acid. What is acetic acid? CH3COOH. So because of the En difference. What is En? electronegativity difference. What you write? You write O minus and you write H plus. Understood what I am saying? That's the reaction with what, Nana? Acetic acid. Yes. Now see, acetylene is react with what, students? Acetylene is react with acetic acid. Now you get CH3COO minus dot H plus, acetic acid, weak acid. Now the one of the pi bond shift like this now, O minus C plus. Now simple logic. Now the H plus ion, what I am saying, the H plus ion attack on the C minus and CH3CO minus ion attack on the C plus. Now from that what you get? We get CHOCOCH3 double bond CH2 got. Now this is called vinyl acetate. And what I am saying? Vinyl acetate. In the vinyl acetate, again the pi bond is weak one. To this vinyl acetate, again by adding of what? Again by adding, because the pi bond is weak one now. Again by adding of acetic acid, CH3CO minus H plus. You ask a question, why is acetic acid is added again? Simple as because pi bond is weak one now. Because pi bond is weak one, that's why pi bond again break down. The bond shift like this, negative charge, positive charge. You have one doubt. Sir, why sir the bond shift like that? Because this oxygen have the two lone pairs now. The lone pair stabilize the electron deficiency nature of the positive charge of the carbon. The lone pair stabilize the electron deficiency nature of that carbon. Understood? Now again the H plus ion attack on the CH2 minus and CH3CO minus ion attack on the C plus. From that what you got? You got CH3, right? And you get CHOCOCH3. What you get? OCOCH3. Again what you get? You get OCOCH3. That is called ethane acetate is forming. What is forming? Ethane acetate is forming. Understood what I am saying? So what you get? Ethane acetate is forming. Simply called acetate. Ethane acetate is forming. Simple explanation. Repeat explanation once again. So what is acetic acid? It gives H plus ion slowly. H plus ion attack on the C minus. CHCO minus ion attack on the C plus. And you get like that. Again pi bond is weak one. The pi bond shifted to one side. Now you have one doubt. Why is the pi bond shift like that? When pi bond shift like that, the C plus is stabilized by lone pair conjugation of the oxygen. And you get what? Acetylene acetate. What you get? Acetylene acetate, simply called what? Ethane diacetate. Tell me now what is the answer you got? Ethane diacetate is forming. Understood what I am saying? This is a simple explanation. Only reaction with the water is completed. Acetylene gas react with the water, you get what? Vinyl alcohol or what? Acetaldehyde reaction completed. And next one, reaction with what? Reaction with the H2 gas. Now, the third one, with what? With H2 gas. It is a very simple reaction. When reaction with H2 gas, now what you write? CH, triple bond, CH. Now to that, sending off 2 moles of H2 gas. Simple logic. For 1 pi bond, 2 H atoms. For 1 more pi bond, 2 H atoms in the presence of the catalyst Rani nickel, and you get what? And you get ethane gas. What you get? Ethane gas. This is called Sabatier. Tell me. Sabatier Sanderens. Sabatier Sanderens reduction. Simple statement, students. Read the statement once again. Sabatier Sanderens reduction. That is the reaction with what gas? H2 gas. If any possibility of the name reaction is there, better to write the name reaction also, students. Simple logic. For 1 pi bond, 2 H atoms attack. For 1 more pi bond, 2 H atoms are attacked. And you get what? Ethane gas you got. That reaction is called what? That reaction is called Sabatier Sanderens reduction. Nice, clear? Yes. So right. And the fourth reaction is what? With the halogens. Fourth reaction is what, students? With the halogens. This again is, what is halogen? X2. X2 on heating, what you get? X plus X minus. X2 means what you get? X plus plus X minus. Now what you get? Acetylene gas combines with what? X2 gas. X2 gas means what you write? X plus is a electrophile. X minus is called what? Nucleophile. Now the pi bond shifted to one of the bonding atom side. When pi bond shift like this, you get negative charge and you get what charge? Positive charge. Now X plus attack on the C minus, X minus attack on the C plus. From that what you get? CHX double bond CHX. This is called dihaloethene. In the name dihaloethene. Now again pi bond is weak now. Array Nana, one more pi bond is there, brother. See, simple logic. Because one more pi bond is there. So because of the one more pi bond, again what you write? X plus, X minus. Now pi bond shifted any one of the side, no problem. Because of the same carbons. Now again, X plus attack on the C minus, X minus attack on the C plus. Now what you got here? You get CH, X2, single bond CH, X2. This is called tetrahaloethane form. Tell me what is forming? Tetrahaloethane is forming. Simple logic, no confusion. Simple explanation now. This is reaction with what? X2 gas. So when reaction with H2 gas, X2 gas what is forming? Tetrahaloethane is forming. Any doubt you have it? Understood what I am saying? Very good, Nana. So that is completed. Chemistry is very easy, not so much difficult, brothers. And next one is what? Hydrogen halide. But the next one, the fifth reaction. So 4 reactions completed now, and go to the 5th reaction, that is what? With hydrogen halide. What is hydrogen halide? HX. What are the examples of hydrogen halides? Hydrofluoric acid, hydrochloric acid, hydrobromic acid, hydroiodic acid. Where the bond length is more? In the bond length, more for hydroiodic acid. Bond length is more, therefore the bond energy is less. What I am saying? Bond length is more, bond energy is less. Because of that reason, and what you get? Now simple logic. Take the example of the acetylene. Now to this acetylene, adding up the one of the best example of hydroiodic acid, because the bond length is more, bond energy is less. H plus, X minus, HA and heating. In organic chemistry, without heating, there is no reaction. Now the pi bond is shifted to one of the bonding atom side, giving out negative charge, giving out the positive charge. Now H plus ion attack on the minus, I minus ion attack on the plus. From that, what you get? You get CHI double bond CH2. This is called vinyl iodide. Tell me, students, vinyl iodide. In the vinyl iodide, one more pi bond is there. The pi bond itself is weak now. H plus, I minus on heating. Here the pi bond shifted to this carbon side. When shifted this carbon side, giving up negative charge, giving up the positive. Now the C plus is stabilized by lone pair conjugation. Simple logic, students. I didn't have the lone pairs now. The lone pair of the ion stabilize the positive charge of the C plus. Now again, H plus ion attack here, and I minus ion attack on the C plus. From that, what you get? You get CHI2 single bond CH3. That is called diiodoethane. Then the answer what you write? Diiodoethane is formed. That is the reaction for hydrogen halides. It's very easy, no confusion. So pi bond shifted to one of the carbons and you get carbon with negative charge and carbon with positive charge. What is HX? Hydrochloric acid, hydrochloric acid, hydrobromic acid, hydroiodic acid. Understood now? Hydroiodic acid is bond length is more, bond energy is less. That's why. So I minus ion attack on the C plus, H plus ion attack on the C minus, and you get vinyl iodide. Yeah. No. Yes. What is your doubt, Nana? Yeah, it's not 90% is not so much difficult, Nana. 90% is not so much, so somewhat difficult for average students. It's not so easy to get 90% for average student, Naresh. It is somewhat difficult for average student. Now again I minus and attack on the C plus, H plus and attack on the I minus, and you get what? Diiodoethane. Now this is over. And take next one, sixth reaction with what? Ammonical silver nitrate and ammonical cuprous chloride. That is very, very important, the sixth reaction. With what I am writing? First one, with ammonical silver nitrate. Tell me, with ammonical. Naresh, first year is not enough, no. First year as well as second year, both have the equal priority for the objective exam. For the objective exam, only from the first year the questions are not given. Second year also both 50% are important. Right, no. Not go like that. Definitely you get some difficulties facing. With ammonical silver nitrate solution. What I am saying, Nana? With ammonical silver nitrate solution. Simple explanation, Nana. See, this is the acetylene gas. In the acetylene gas, the carbon is what? sp carbon. Carbon is sp carbon. So because of what? Now, first year you can focus and second year you can focus, Naresh. Okay, first year you can focus and second year you can focus. Because of sp carbon is the 50% of what? S character. Because of the sp carbon percentile 50% is satisfied, the sigma bond electrons are moving towards the carbon side. C minus H plus. Sigma bond electrons are moving towards carbon side. C minus H plus. React with what? Ammonical silver nitrate solution. That means what you write? Ag plus dot NO2 minus. Ammonical means what? Ammonium hydroxide. NH4 plus dot OH minus. Understood what I am saying? Yes, no. Yeah, long term is okay. Now it's easy to get 90%. Now see, simple explanation I am writing. Now this H plus ion attack on the C minus. This Ag plus ion attack on this side C minus. Now H plus ions combines with what? H plus ion combines with this OH minus ion. Loss of 2H2O. How you get H plus combines with OH minus? Water loss. H plus combines with OH minus. Water loss. Now NH4 plus combines with NO3 minus, you get ammonium nitrate. What you get? Ammonium nitrate, and from that you get what? Silver acetylide is forming. Excellent. What you get? Silver acetylide is forming. You get silver mirror precipitate forming. Silver mirror observed. Silver mirror observed over walls of the test tube. Over walls of what? Over walls of the test tube. Simple explanation, no confusion. Silver mirror is observed over the walls of the test tube. Understood what I am saying? Beautiful bit, no confusion. So the carbon is sp carbon. So because of sp carbon, 50% of s character is there. The sigma electrons are moving to carbon side C minus H plus. Because of 50% of s carbon, carbon is the more En value. That's why C minus H plus. Now this Ag plus ion attack on the C minus. Again the Ag plus ion attack on the C minus. H plus ion combines with OH minus, water loss. H plus ion combines with water loss. NH4 plus NO3 loss of the ammonium nitrate, and with silver mirror absorbed over the walls of the test tube. And one more reaction is there here with the ammonical cuprous chloride solution. What I am saying? With the ammonical cuprous chloride solution. So cuprous chloride solution with ammonical cuprous chloride solution. Now how you write this reaction? It's very easy. CH, triple bond CH, and to that adding of cuprous chloride CuCl2 plus ammonium hydroxide. Now because of the sp carbon, what you write? C minus H plus, right? Because of the sp carbon, C minus H plus. Now what happens here? Now the simple logic again. Now H plus ion combines with this OH minus ion, water loss. H plus ion combines with this OH minus ion, loss of the water. Very easy. Loss of 2H2O. NH4 plus combines with what? Cl minus, loss of 2 moles of the ammonium chloride. Now the Cu plus attack on the C minus. Again the Cu plus attack on the C minus, and you get what? And you got cuprous acetylide. Tell me what you got now? Cuprous acetylide forming. Now this cuprous acetylide is a what? The cuprous acetylide is a red PPT is observed. So the same, the marker PPT is observed, that is a red PPT. Simple explanation, Anna. Because the sp carbon is 50% of s character, the carbon has the sp carbon has the most En value. Sp carbon has what, Nana? Most En value. Naresh, understood what I am saying? By the long term, the getting over 90% is very easy now. By the IP is very somewhat difficult for the average students, right? Now, to the C minus attack of CU plus, and you get Q plus acid line, that is a red PPT is observed in the test tube. So this is the one of the beautiful 8 marks question. So these kind of questions are important. Sometimes in the examination of the 8 marks questions, how acid may react with ammonium silver nitrate, how acid may react with ammonium chloride, how acid may react with acetic acid, like that the questions are given. Understood? Already these are the previous questions. The questions which posted by the Groups Academy, already these are the previous questions now. Describe any 2 minutes of preparation of what? Any 2 minutes of preparation of the benzene. Explain the halogenation, alkylation, acylation, nitration, sulfonation of the benzene. Yes, first we go for the 2 minutes of preparation. First minute from acetylene gas. From which gas, students? From acetylene gas. Simple explanation. By passing 3 moles of the acetylene gas, by passing 3 moles of the acetylene gas through the red hot iron tube. To what I am saying, through the red hot iron tube, by passing 3 moles of acetylene gas through the red hot iron tube, and you got benzene liquid. Tell me what is forming? Benzene liquid is forming. Simple reaction to the first method of the preparation. But in the examination, you write the statement also. How you write the statement? 3 moles of acetylene gas passing through red hot iron tube. Acetylene gas polymerized forms benzene liquid. You write like that. Understood what I am saying, students? And take the second example. The second one is what? From what? From phenol. From what, Nana? From phenol. What is phenol? So phenol is nothing but carbolic acid. What is phenol? Nothing but what, students? Carbolic acid. Now simple explanation. Now to the phenol adding of what? Alcoholic zinc dust. To the phenol heat with what? Heat with the alcoholic zinc dust. When heat with alcoholic zinc dust, zinc is +2 state, oxygen is -2 state. What I am saying? Zinc is what, student? +2 state, and oxygen is what, student? -2 state. And loss of the zinc oxide. Tell me. Loss of the zinc oxide as solid, and you got a benzene. So this is the preparation of what? Preparation of the benzene from the phenol. How you write the statement? Phenol is heated with alcoholic zinc dust. Tell me. Phenol is heated with alcoholic zinc dust by the reaction forming. Removal of the oxygen is called what? Reduction. Zinc in the 0 state, zinc becomes what? +2 state. So 0 becomes +2 means what? Reduced. That means phenol is reduced by the zinc dust. Phenol is what, Nana? Reduced by the zinc dust, and we get zinc oxide, and we get from the phenol. Simple explanation. Understood what I am saying, students? Yes. And next one is what? Halogenation, alkylation, acylation, nitration, sulfonation. First one, halogenation of the benzene. Now see, what is the meaning of halogenation? Halogenation means addition of the halogen, X2. X2 means what you write? X2 means in the presence of the Lewis acid catalyst. What is the Lewis acid? Anhydrous ZnCl2. Lewis acid is a catalyst. And on heating, and then what? Heating, one of the bonds shifted to this side. You get X minus, you get what? X plus. Now this X minus forms a day2 bond with what? Day2 bond with Zn(X2). Is a Lewis acid now. What is Lewis acid? Electron pair acceptor. That's why X minus from day2 bond with Zn(X2). Now the X plus ion is free. What is X plus ion? Electrophile. In the benzene, the most of reactions are examples of what? Electrophilic substitution reactions. That's right. Now to the benzene. Simple explanation, student. Now in the benzene I am writing like this. So this is the benzene C6H6 now. Benzene is what? C6H6. If I keep the H like that. Now by addition of what? X2. In the presence of what? Lewis as the what? Zn(X2) is a Lewis acid. Now what happens? Now this hydrogen leave out as what? The hydrogen leave out as a H plus. Now this H plus combines with what? What is X2, Nana? X plus, X minus. Loss of HX. Loss of what? HX. H plus combines with what? X minus. Loss of HX. Now here sigma bond is there. Sigma bond means nothing but what? Negative charge. Sigma bond is nothing but what? Negative charge. Now X plus ion attack on sigma bond with negative charge, and you got halobenzene. What you got? Halobenzene. This is the answer. And you got halobenzene. So what is halobenzene? C6H5OX. This is the formula of the halobenzene liquid. Simple, Nana. Repeat once again because somewhat difficult this one. Alright, Nana. In the benzene, adding of halogen. What is halogen? X2. X2 means what you write? X plus, X minus. Lewis acid is a catalyst. X minus is removed by the Zn-X2 of Lewis acid. Now X plus ion is free. The free X plus ion attack on the benzene with sigma bond. Sigma bond is negative charge and you get halobenzene. Understood what I said? And the mole of what? HX. That is called halogenation. Clear what am I saying? And second one, alkylation of the benzene. Again, the simple explanation. For alkylation, I can use the methyl chloride in the presence of anhydrous AlCl. Lewis acid as the catalyst. So for alkylation, we can use methyl chloride in the presence of anhydrous AlCl. Yes, yes. So to the methyl chloride, adding of anhydrous AlCl. The bond shifted towards its students, chlorine side, Cl minus CH3 plus. Again you have doubt. Why is the bond shifted to chlorine side? Because chlorine is the more ion value compared to carbon. Arey Nana, in the organic chemistry, no heating, there is no reaction. Nana. In the organic chemistry, no heating, there is no reaction. That's why, so they just as what? Cl minus dot CH3 plus. Simple logic. Now from that, in the benzene, I am writing the benzene like this, any problem? No, this is the benzene. Then the hydrogen removed as what? Hydrogen removed as H plus. Now hydrogen removed as H plus removed by the Cl minus in the form of what? HCl. Now the CH3 plus methyl carbocation attack on the benzene with what charge? Negative charge. Tell me. The methyl carbocation attack on the what? The methyl carbocation is a electrophile. Methyl carbocation is what? Electrophile. The methyl carbocation electrophile attack on the benzene with negative charge and attack like that, and you get what? Methyl benzene. Now this methyl benzene is called toluene liquid. Tell me what liquid is formed, students? Toluene liquid is formed. One of the beautiful bit. Simple logic, no explanation. Now the CH3 plus attack on the benzene with what charge? Negative charge. That's why CH3 plus attack on benzene with negative charge, and you get toluene liquid is forming. That is called methylation of the benzene. Tell me what I am saying, students? Methylation of what, Nana? Benzene. Understood what I am saying? That is called alkylation. That is, Nana, is very easy. For alkyl, we take the example of what? CH3 plus and Cl minus. Cl minus I remove the hydrogen as H plus and electrophile attack on the benzene. In the benzene, the reactions are examples of what? Electrophilic substitution reactions, and you get toluene. That is the second reaction, alkylation. And come to the third reaction. The third reaction is acylation. What is the third reaction given? The third reaction given as acylation. For acylation, we can use what? Acetyl chloride. What is acetyl chloride? CH3COCl. In the presence of what? Anhydrous ZnCl2 as the catalyst. Again, the same explanation. Again, what is the same explanation here? Because of the electronegativity difference, the chlorine removed as what? The chlorine removed as a Cl minus. The carbon get what charge? Positive charge. Understood what I am saying? Now this is called what? Electrophile. So what is electrophile? Acetyl carbocation is electrophile. Again the same explanation, students. Now this is the benzene. Understood what I am saying? Now to this benzene, adding of what? Acetyl chloride. What is acetyl chloride? CH3CO plus dot Cl minus. What is the catalyst used? Anhydrous ZnCl2 used as a catalyst. Now the simple explanation now we wrote. Here in the benzene, the hydrogen removed as what? The hydrogen removed as a H plus ion. Right? Now the CH3CO plus attack on the benzene. Tell me, CH3CO plus attack on the what? Nana? Benzene. That is called electrophilic substitution reaction. H plus remove the Cl minus in the form of HCl, and what you got? And you get benzene COCH3. That is called what? That is called acetophenone liquid. What we get, students? You get acetophenone liquid. One of the beautiful bit. Here the electrophile is what? Electrophile is CH3CO plus. The CH3CO plus attack on the benzene with what? Sigma bond. Sigma bond carries what charge? Negative charge. Example of electrophilic substitution reaction. Yes, no, Chandahasni. Yes, next way to that, Nana. Don't worry. Go to the next way to that, Chandahasni, right, Nana? And go to the next one, sulfonation. Sulfonation of the benzene. See, what is the meaning of sulfonation? Addition of the sulfuric acid. Now, in sulfuric acid addition, what is the formula of sulfuric acid? H2SO4. This H2SO4, you are a student of easy understanding. I am writing H2O dot SO3. What I am writing, students? H2O dot SO3. Both are combined, you get H2SO4. For your understanding of explanation, I am writing like that. Understanding of explanation, Anna, I am writing like that. H2O dot SO3. Now, Buji, now simple explanation. Sulfur En value 2.5. Electronegative value of sulfur is 2.5. Oxygen En value 3.5. Which is more En value? Oxygen is more En value. This way, get sulfur have positive charge, oxygen have negative charge. Right? Now, to the benzene, I am making hydrogen like this. Now, adding of what? SO. What is SO3? S double bond O. Right? S double bond O. And S double bond O. The pi bond shift like this. What we get? Negative charge and positive charge. Now here the hydrogen removed as what? All I said. Hydrogen removed as a H plus. Right. Now this is a sigma bond. Sigma bond means what charge? Negative charge. Now the negative charge of sigma bond taken out by the S plus. Now H plus and attack on the O minus. Simple explanation. Now water is lose out none, but what comes as this here? Now what you get? And you get here SO3H. That is called benzene sulfonic acid. Tell me what you get? Benzene sulfonic. You get benzene sulfonic acid. Simple explanation, no confusion. That is called what, student? Sulfonation of the benzene. Tell me what I am saying? Sulfonation of the benzene. Simple explanation, no confusion. Regarding the sulfonation of the benzene liquid, what you get? S plus attack on the benzene with negative charge, and you get benzene sulfonic acid. One of the beautiful explanation, Nana Hasni now is clear what I am saying? That is called what? Sulfonation of the benzene. Clear what I am saying? Yeah. And the fifth reaction is what, Nana? Nitration of the benzene. What is the fifth reaction? Nitration of the benzene. Now regarding the nitration of the benzene, fifth reaction of the essay question, now go for nitration of the benzene. Now regarding the nitration of the benzene, here what I am saying, regarding nitration of the benzene, we can use nitration mixture. We can use what, Nana? Nitration mixture. So what is nitration mixture? Nitration mixture nothing but what, Nana? 1:1 ratio of concentrated nitric acid and sulfuric acid. That is called nitration mixture. Repeat that once again, Nana. What is the meaning of 1:1 ratio of 10 ml of nitric acid mixed with 10 ml of the sulfuric acid? That is called 1:1 ratio of nitric acid and sulfuric acid, called nitration mixture. Now, actually here in a nitration mixture, the both species are react. What I am saying? The both species are react. You get what? You get NO2 plus dot OH minus. When both species are react. Now take the example. Now take the example of this benzene. To this benzene, when adding of that nitration mixture, what is there? NO2 plus is there, dot OH minus is there. Now here one of the hydrogen removed as what? One of the hydrogen removed as a H plus on heating. Understood? Now H plus combines with this OH minus. Loss of the water. Simple logic, Nana. That OH minus remove the hydrogen as H plus OH minus loss of the water. Now the NO2 plus, NO2 plus is what? NO2 plus is electrophile. What I am saying? NO2 plus is electrophile. NO2 plus electrophile attack on the binding with what charge? Sigma bond is a negative charge, and you get nitrobenzene. Tell me, student, what you got? You got nitrobenzene. So what is nitrobenzene? Nothing but isle of methane. What is nitrobenzene, student? Isle of what? Methane. This is called nitrobenzene. Understood? This is one of the beautiful essay question. One of the what? Beautiful essay question. Understood what I am saying? Yes, yes. And go to next question. Explain the following equation. Wood's reaction is the foremost question, student. This is carries the 2 marks, and this is the carries the 2 marks. This is the foremost question. Understood, Nana? Yes. First, Wood's reaction. See how you write the Wood's reaction. Simple explanation. In the Wood's reaction, what is taken? 2 moles of alkyl halides. Tell me what I am saying. 2 moles of the alkyl halides with the similar nature, with the same kind, with the similar kind, react with the sodium metal. What I am saying? React with the sodium metal in the presence of dry ether solvent. What I am saying? In the presence of dry ether solvent forms alkane. Forms what, students? Forms alkane. Understood? What am I saying? Repeat the statement once again. Tell me, what is Wood's reaction? 2 moles of the alkyl halides with the similar kind. Similar kind means what? Same kind. React with the sodium metal in the presence of the dry ether. 2 moles of the alkyl halide with similar kind. React with the sodium metal in the presence of the ether forms what? Alkane. Simple example taken. CH3CH2Cl. React with the sodium metal. Again what you write? Cl CH2Cl because of the similar kind. This is called ethyl chloride. Ethyl chloride. Similar kind. Similar kind. In the presence of what solvent? Dry ether solvent on heating. Now loss of what? Now loss of the NaCl. So what, student? Loss of the 2NaCl and forms what? And forms butane. Tell me what is forming, student? Butane gas is forming. Understood what I am saying? Simple explanation, that is called Wood's reaction. Here ethyl group is there, there ethyl group is there, ethyl group is combined and forms what? And forms butane. It's called Wood's reaction. And come to the simple nana. What is the Wood's reaction? Tell me. 2 moles of the alkyl halides of what? Same kind. Same kind means what? Ethyl chloride take here, you take ethyl chloride there. Methyl chloride take here, you take methyl chloride there, like that. React with the sodium metal in the presence of what? Dry ether solvent forms what? Forms the alkane. Alkane is what? Butane. And see next one. Kolb's electrolytic method. Now what is the concept of the Kolb's? That is also very easy. Now see the statement. For the 2 marks questions, before writing the statement, equation writing is very important. Don't miss the writing of the equation, right? So how we define Kolb's? Now see, Kolb's electrolytic method. Kolb's electrolysis, how you define, is defined simply like this. Kolb's electrolysis defined as aqueous solution. What I am saying? Aqueous solution of sodium acetate. Aqueous solution of the sodium acetate subjected to electrolysis. Tell me what I am saying, student. Aqueous solution of the sodium acetate subjected to electrolysis forms ethane gas at anode with liberation of H2 gas. Liberation of student H2 gas. Repeat the statement once again. Aqueous solution of the sodium state subjected to electrolysis. Tell me, aqueous solution of the sodium state subjected to what? Electrolysis. Okay, forms what gas? Ethane gas at anode with liberation of H2 gas. That is the statement. Now, how you fulfill the statement? How you fulfill the statement? Simple as sodium state CH3 COO minus Na plus. You take the two moles CH3 COO CHCO minus Na plus. So in presence of the water, aqueous solution H plus OH minus, right? So subjected to what? Electrolysis. For process of this electrolysis, we can use anode comma cathode. Now from that, what you get? Now the Na plus ion combines with OH minus, Na plus combines with OH minus, forms what? Loss of 2 NaOH aqueous solution. H plus ions moving towards what side? Cathode side. Liberation of what gas? Liberation of the H2 gas. Now the anions are moving towards what side? Anode side, and liberate what? Liberate CO2 gas. Simple logic. So this anion, the anion CO minus moving in the form of CO2 gas. What is the left part? Left part is methyl, and ethane gas is liberated. Tell me what is liberated, student? Ethane gas is liberated. So this will too happens at what? This will too happens at cathode. Understood? Cathode is a -4. This will too happens at what? This will too happens at anode. Anode is a what pole? Positive pole. Simple logic. Understood, Nana? So this is the concept of what? Poles electrolysis. And simple reaction, Nana. Sodium salt, because of the salt, we write as a ion. Sodium is a metal, Na plus O minus, Na plus O minus. Hydrolysis means what? H plus OH minus. Na plus combines with OH minus, forms NaOH. Na plus combines with OH minus, forms aqueous solution of NaOH. H plus ions moving towards what side? H plus ions moving towards the cathode side. Undergo reduction, liberation of H2 gas. Liberation of what gas? Nana? H2 gas. Simple explanation. Now the anions are moving towards the anode side, because anode is a positive pole. Anode is what? Anode is a what pole? Positive pole. Now the CO minus leave out in the form of the CO2 gas, oxidation. Methyl combined, you get what? Methyl combined, you get ethane gas. Tell me without H Babu. Yes, Babu, tell me without. Tell me without, and I am waiting for you without H Babu. See the next question, Anna. So compare the following reaction, name the ABC. Yes, calcium carbide. What you write? Ca plus 2 ... And what you write? C minus. Right? C minus. It will bond like that. So hydrolysis means what? Water. Now H plus ions water combines with what? C minus, you get what? You get acetylene gas. So acetylene gas is liberated. Understood, Nana? Now this acetylene gas passing through what? Red hot metal tube. Now the 3 moles of acetylene gas is polymerized. What I am saying? 3 moles of acetylene gas is polymerized, because when passing through red hot metal tube and forms the B. Now what is the B forming? The B forming is benzene is forming. Understood? So A is what? A is the acetylene gas. Acetylene gas also called what? Methyl gas, and forms benzene. Now by adding up the methyl chloride, all I said, chlorine is the best living group, Cl minus and CH2 plus, because AlCl is a Lewis acid. Understood, student? Now here recovered is what? CH2 plus. That's why in the benzene, one of the hydrogen removed as what? One of the hydrogen removed as a H plus. What I am saying, Nana? One of the hydrogen removed as what? H plus. Now H plus ion comes Cl minus and loss of what? HCl. Now the CH3 plus, else H plus loss of sigma bond is a negative charge. CH3 plus added on the CH3 minus and we get C. That C is what? Toluene. What is toluene? Toluene is what? Methyl benzene. Tell me toluene means what, Nana? Methyl benzene. Simple explanation, no confusion. So A is what, student? A is acetylene gas. Acetylene gas also called what, Nana? Ethane gas. Now acetylene gas is passing through the red hot iron tube. 3 moles of the acetylene is polymerized, forms benzene, because benzene is stability. Now, to that benzene adding of what? Methyl chloride. CH3 plus is electrophile. The CH3 plus electrophile attack on the benzene. The hydrogen ion has H plus and loss of HCl. Benzene with negative charge CH3 plus is attacking, and you get what? Toluene liquid is forming. What I am saying now? Toluene liquid is forming. Understood what I am saying? Yes, this is our today explanation. Have any doubts? Please post your doubts. Yes, these questions are over. In organic chemistry, questions are completed in the span of 1 hour time. So three long essay questions completed, and 4 marks questions 2 or 3 completed. Right, Nana? Have any doubts, brother? Please tell me. Is clear, Nana? Chandrahasni, Naresh. Yes. Thank you very much.